Hello everyone, here is a question from quantum mechanical model of atom. Calculate the uncertainty in position of an electron if delta V is equal to 0.1% and velocity is equal to 2.2 times 10 to the power 6 meter per second. Here the velocity is given, but there is 0.1% uncertainty in the velocity. Therefore, the actual delta V should be equal to 0.1 divided by 100 times 2.2 times 10 to the power 6 meter per second. This we can write it as 10 to the power minus 1 divided by 10 to the power 2 times 2.2 times 10 to the power 6 meters per second. So, this will become 10 to the power 4. We have 10 to the power minus 1 here. So, it will become actually 10 to the power 3. So, actual delta V is equal to 2.2 times 10 to the power 3 meter per second. Now, let us calculate the uncertainty in position. As per Heisenberg uncertainty principle, we know that delta x times delta p should always be greater than or equal to h divided by 4 pi. Delta p we can write it as mass times delta v. Therefore, delta x times m times delta v should be greater than or equal to h divided by 4 pi. H is the Planck constant, m is the mass of the electron. M is equal to 9.1 times 10 to the power minus 31 kg and Planck constant is equal to 6.626 times 10 to the power minus 34 joule second. 1 joule is equal to 1 kilogram meter square per second square. Therefore, H is actually equal to 6.626 times 10 to the power minus 34 kilogram meter square per second. So, let us substitute all these values now. Therefore, delta x is greater than or equal to 6.626 times 10 to the power minus 34 kilogram meter square per second divided by 4 times pi value is 3.14 times mass of electron is 9.1 times 10 to the power minus 31 kg times delta V is 2.2 times 10 to the power 3 meter per second. Let us cancel the units that are common. So, what we will have is only meter, which is for the position. And now 3.14 and 6.626 we can approximately take this as 2.2 we can cancel it out. Therefore, delta x is greater than or equal to, in the numerator we have 10 to the power minus 34 meter divided by, let us take 9.1 as 9, therefore 4 times 9 is 36. Here we have 10 to the power minus 31, here we have 10 to the power plus 3. Therefore, that will become 10 to the power minus 28. When this 10 to the power minus 28 goes up, it will become positive. Therefore, delta x is greater than or equal to 1 by 36 times 10 to the power minus 6 meter. Let us find out 1 by 36. We cannot divide, therefore, put a 0, 0 point. We still can't divide, put another 0. And now 2 times 36 is 72, remaining 28. We can't divide, put a 0. 7 times 36 will be 252 and remaining will be 28. This will be keep going. Therefore, delta x is greater than or equal to 0.027 times 10 to the power minus 6 meter, or we can also write it this way, delta x is greater than or equal to 2.7 times 10 to the power minus 8 meter. So, that is the uncertainty in the position of the electron.